Let me try to tell you something about the fundamentals of alcohols. Alcohols can be classified on the basis of number of OH groups attached. OH groups. Depending upon the number of OH groups attached, alcohols can be classified as monohydric alcohols or polyhydric alcohols. Say, for example, ethanol is monohydric alcohol. Glycol, this is glycol. It is also called ethylene glycol. Ethylene glycol is a dihydric alcohol. And this is called glycerol. It is a trihydric alcohol. Glycerol is a trihydric alcohol. And the second classification, it depends upon whether the carbon to which the hydroxyl group is attached, whether it is sp3 hybridized or sp2 hybridized. If it is sp2 hybridized, as in the case of CH2, double bond CH, OH, it is called enol. Enol. En for the unsaturation and all for the alcoholic group. It is called enol. It is an unsaturated alcohol. And also, alcohol can be primary, secondary, and tertiary. So what is the primary alcohol? Primary alcohol, the OH group is attached to primary carbon atom. Primary carbon atom. What is a primary carbon atom? A carbon attached to only one more carbon. That is a primary. So for example, CH3, C, H, H, OH. Now this carbon is called primary carbon atom. Similarly, suppose I write an unsaturated compound. See here, this carbon is a primary carbon. Similarly, C6H5, CH2OH. This is a primary carbon. Actually, if you remove the OH group and keep a hydrogen here, you will get an alkane. In any alkane, one hydrogen is removed and the carbon has a vacant bond for the attachment of any other functional group, then that particular part of the organic compound is called alkyl group. This is called alkyl. So this is an alkyl alcohol. See, this carbon, which is attached to a carbon with a double bond, it is called allylic carbon. This carbon is called allylic carbon. Allylic carbon. There are a few questions asked from this. This carbon is called allylic carbon. So this is allyl alcohol, allyl. This carbon, which is attached to a carbon of the benzene ring, which is also sp2 hybridized, but it is in a ring structure. then this carbon is called benzylic carbon, benzyl alcohol, benzylic carbon or benzyl alcohol. But all these things are primary alcohols. All these things are primary alcohols because the carbon to which the OH group is attached is a primary carbon because it is attached to only one more carbon. Suppose in a different situation, CH3, C, I replace one of the two hydrogens with another methyl group. Need not be methyl group always. That can be any other chain, but a carbon should be attached here. Now this carbon becomes a secondary carbon. This is secondary alcohol. Similarly, in the allylic group also, one hydrogen in the allylic carbon can be replaced by another carbon containing chain. That is also possible. It is also a secondary alcohol. Similarly, even in the benzylic carbon, if I remove a hydrogen and it is attached to another carbon chain, it is secondary benzylic carbon. These are all the examples for secondary alcohol. And then tertiary alcohol, if that remaining one hydrogen is also replaced by a carbon chain, CH3, C, here also CH3, and here also CH3, OH. This is a tertiary alcohol. Similarly, in the allylic system also, CH, C, another H is also replaced by CH3 and OH. This is tertiary allylic carbon. Even this benzylic carbon can also be tertiary if that remaining hydrogen atom is also replaced by another carbon chain. So in order to be very simple, I am replacing the hydrogen with a methyl group. Need not be methyl group. That can be any carbon chain. But a part of that carbon chain with a carbon is attached to this carbon. Now this is also an example of a tertiary benzylic carbon. So tertiary benzyl alcohol is this. Tertiary allyl alcohol is this. And this is tertiary alkyl alcohol. So the classifications, first the classification of alcohol is based upon the number of OH groups present. And secondly, the classification is based upon the nature of the carbon atom to which the OH group is attached. And you are all, I think, very familiar with the nomenclature of alcohols. See the nomenclature of alcohol. I've taken a few examples from the textbook. It's not a very new thing for you. It's only a normal textbook exercise. First, I write a compound, CH3, CH2, CH2, CH, CH2, CH3, and here CH2OH. Now you look here, there are so many things we can discuss at this point. The OH group is attached to a carbon, and that carbon is attached to only one more carbon. Therefore, this is a primary alcohol. Suppose If the OH group is attached to this carbon, that will be a secondary alcohol. If the OH group is attached to this carbon, replacing this hydrogen, it will be a tertiary alcohol. Here, secondary alcohol. Here, secondary alcohol. And here, primary alcohol. So the primary alcohol, how many primary alcohols are possible with this molecular formula? Here a primary alcohol, here a primary alcohol, here a primary alcohol. How many secondary alcohols are possible? Here a secondary alcohol, here a secondary alcohol, here a secondary alcohol. How many tertiary alcohols are possible? Only one tertiary alcohol. So from this, even though we have taken this as an example for nomenclature, we have to bring in all the fundamental idea into that. So this is a primary alcohol, first of all. Now I am going to number the carbon atoms. Carbon atoms are to be numbered in such a way that that carbon which contains the functional group should get the least number. Therefore, I have to start the numbering here. So this is 1. Now, the longest chain is the parent chain. So if I go towards my right, 1, 2, 3, 4. If I count the carbons towards my left, 1, 2, 3, 4, 5. So the longest chain is towards my left. So it has 5 carbon atoms. So the numbering is 1, 2, 3, 4, 5. In the second carbon position, an ethyl group is attached. I can take the entire group as ethyl group. So the name of this compound is 2-ethyl pentane, pentane for 5 carbon, 1 all. This is the name of this carbon, this alcohol. Look at another alcohol, CH3, CH2, CH, OH, CH2, C, CH3, CH3, Br. This is an example given in the textbook. Now, from your previous knowledge, certain things you can discern about this alcohol. First of all, find out whether it is a primary alcohol or a secondary alcohol. See, look at the carbon to which the OH group is attached. So this carbon is further attached to 2 more carbon atoms. So it is a secondary alcohol. If the OH is here primary, if the OH is here secondary, OH here secondary, OH here secondary, then if OH is found in this carbon, primary, if the OH is found in this carbon, primary, replacing the bromine, if OH is present, here it is tertiary alcohol. Now I want to number. Now, while numbering, you have to start from any terminal because the OH group is found in the middle. But in this case, the carbon containing the OH group can be considered as a terminal because you need not run like this. It need not run like this. 1, 2, 3, 4, 5, 6. You need not run like this. I have to start from here because it's chain. So now, as the OH group is found in between, either you have to count in this manner or you have to count in this manner. Even if you count including this methyl group, it is not going to make a difference in the count because another methyl group is here. So totally 1, 2, 3, 4, 5, 6 carbons are there. Because why I counted in this fashion? So I have to count in such a way that the carbon to which the OH group is attached gets the least number. If I count in this fashion, 1, 2, 3, 4, the alcoholic group is attached to fourth carbon. If I count in this fashion, 1, 2, 3, 4, 5, alcoholic group is attached to the third carbon. Therefore, this is the right method where the functional group is getting the number least one. Now you may get a doubt. This is also a substituent and bromine is also a substituent. Which substituent has to be given the preference, for which you have the preferential order? First acid, then sulfonic acid, then like that you have order. In that order, bromine, on comparing with the hydroxyl group is given the most preference. Therefore, as the hydroxyl group is given the most preference, we have to start naming like that. This is, first of all, the parent hydrocarbon, hexane. Hexane. In the third carbon, alcoholic group is there. 3-ol, hexane 3-ol. And in the fifth carbon, bromine is attached and methyl group is attached. So the name is going to be 5-bromo, 5-methyl, 5-bromo, 5-methyl, hexane 3-ol. You may think, why can't we write 5-methyl, 5-bromo, hexane 3-ol? The substituents should be named in the order of alphabets. So B comes first and M comes next. Therefore, it is 5-bromo, 5-methyl, hexane 3-ol. This is how it is named. And another compound, this is also found in the textbook, C2H5 thrice COH. See, before naming this compound has to be written in an elaborated manner. Whenever such a simplified molecular formula is given, it is always good to write the elaborated format. So C2H5 means CH3, CH2, which is found thrice. Therefore, this is attached to carbon. And another CH2, CH3 is attached. And then another CH2, CH3 is attached. And then the OH is attached to here. So by nature, it is a tertiary alcohol because the carbon to which the functional group is attached is further attached to 3 more carbon atoms. Now, which is the longest chain? See, the OH group is found in between. So if you move from here 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So whatever may be the direction you go, you are getting 5 carbon atoms. Now, you have to take care that the carbon to which the OH group is attached is getting the least number. So 1, 2, 3, or 1, 2, 3. In all the directions, it is getting the third carbon. Therefore, I rewrite this as a linear compound. Say CH3, CH2, C, OH, CH2, CH3, then CH2, CH3. So this compound can be written as CH3, CH2. For simplification, I am writing like this. C, CH2, CH3, then here OH, and here CH2, CH3. So 1, 2, 3, 4, 5. So it is a pentanol. So the name is a pentan 3-ol. And in the third carbon, an ethyl group is attached. So 3-ethyl pentan 3-ol is the name of this alcohol. 3-methyl pentan 3-ethyl pentan 3-ol. This is the name of this compound. Another compound is CH2 double bond C Cl CH OH CH3. Now, it has a double bond. Double bond is also a functional group. OH is also a functional group. But according to the preferential order, alcohol is given the most importance. So you have to count the carbon atoms in such a way that OH group gets the least number. So we have to start from right to left. So it is 1, 2, 3, 4. So 3 functional groups are there. Chlorine is also there and double bond is also there. While numbering, you have to choose which has to be given the most preference. You need not organize all the 3 functional groups in the preferential order. Which is to be given the most importance? That is the question. So comparing the double bond, the halogen, and the OH group deserves the highest importance. Therefore, the numbering has to be started in such a way that OH group attached to carbon is getting the least number. So now this is going to be, as 4 carbons are there, this is going to be bute. In the third position, double bond is there. Therefore, bute, it is 3-ene. So first I fix the unsaturation position. Bute 3-ene. That ene, that E can be erased. Ene, E-N alone, because all alcoholic suffix is going to be added. Bute 3-ene to all. In second position, all is present. Bute 2-ene to all. In the third position, chlorine is present. Therefore, it is 3-chloro bute 3-ene to all. 3-chloro bute 3-ene to all. Another example. This is also quite interesting. Another example is, look at this structure carefully. A benzene ring. Here is a carbon. OH group is attached here. CH2, CH3. CH2, CH3. Now, look at the side chain. Side chain is lengthier than the ring. So the preference is given to the side chain. Look at the carbon. The carbon is attached to 3 more carbons. Therefore, this is a tertiary carbon. Now you count in such a way that the OH group gets the least number. If you count like this, 1, 2, 3, 1, 2, 3. So either way you can count. It is 1, 2, 3, 4, 5. So as the alkyl group is the parent one, the name bears the name of the alkyl group. Therefore, it is going to be pentanol. Pent, 3-ol. But in the third position, a benzene ring is attached. So benzene ring can be called 3-phenyl. It is a phenyl group. Phenyl. At this point, one thing you should remember, C6H6 is benzene. C6H5, a bond vacancy. It is called a phenyl group. Phenyl. C6H5, CH3 is a toluene. If a hydrogen is removed from toluene, it is called benzyl group. You should know the difference between a benzyl group and a phenyl group. This is benzyl group. This is benzyl group. This is phenyl group. If I remove one more hydrogen, then it is called benzol group. Benzol. See, for example, if I write this C6H5Cl is chlorobenzene or phenyl chloride. Chlorobenzene or phenyl chloride. If I put C6H5CH2Cl, it is benzyl chloride. Benzyl chloride. If I put C6H5CHCl2, it is called benzol chloride. Benzol chloride. If it is C6H5CO, it is called benzoyl. So in this thing, you have to understand all these things. Phenyl, benzyl, benzoyl, benzol, all these differentiations you must understand. Look at this diagram. Suppose if this structure is given. First of all, you have to write the elaborated structure. Look here, it is CH3, an open end, then a carbon. In the carbon, OH group is attached. Then another carbon, which is connected to another carbon through a double bond. Then another carbon. Then another carbon in which the bromine is attached. And then it is again a methyl group. Now we have to fill the vacant bonds. A hydrogen here. 1, 2, 3, 4. A hydrogen here. 1, 2, 3. A hydrogen here. 1, 2. So 2 hydrogens are there. And then here 1 hydrogen. Now this molecule can be clearly written like this: CH3, CH, OH, CH, double bond CH, CH2, CHBr, CH3. Again, this compound is also containing a double bond, a halogen, and a OH group. But preference is to be given to the OH group. Therefore, the numbering starts here. 1, 2, 3, 4, 5, 6, 7. So it contains 7. So it is going to be hept. In third position, ene. Hept 3-ene. In the second position, alcohol group, hept 3-enol. Hept 3-ene-2-ol. In the sixth position, bromine is attached. So 6-bromo hept 3-enol. 6-bromo hept 3-enol. So this is the nomenclature. So like this, number of nomenclatures, and one more question is also asked on the nomenclature. We can do, this is a neat question. A compound C6H14O2 has, wonderful question, two tertiary alcoholic groups. See, the question is indirectly asked. Tertiary alcoholic groups. Write the IUPAC name of the compound. Nothing else is given. The question is very simple. Let me rewrite the question so that you can understand. The molecular formula is given C6H14O2. So as the two oxygen atoms are there are going to be two alcoholic groups. And the two alcoholic groups are attached to two tertiary carbons. What is the IUPAC name? So they are tertiary carbons. So you have to think a carbon, another carbon, another carbon, another carbon. There are two more carbons. If the two more carbons are attached here, two primary carbons and four secondary carbons you will get. There is no chance for tertiary carbon. Therefore, the two carbons, if it is attached here, this is a tertiary carbon. And another carbon is attached here, this is a secondary carbon. Therefore, our condition is satisfied. Two tertiary carbons. In the two tertiary carbons, OH group is attached. So now we have to fill the remaining with hydrogen. So this is CH3, this is CH3, this is CH3, and this is CH3. So if you number 1, 2, 3, 4, so no other longer chain can be found. So the numbering is 1, 2, 3, 4. Therefore, the name of the compound is 2, 3 dimethyl, 2, 3 dimethyl, but 2, 3 diol, two alcoholic groups. So the name of the compound is 2, 3 dimethyl but 2, 3 diol. So that is the name of this compound. Another compound also we can try, CH3, CH, CH, OH, CH3, CH3 is a secondary alcohol. So nomenclature 1, 2, 3. So 1, 2 dimethyl, 1, 2 dimethyl, but, 1, 2, 3. 1, 2 dimethyl propanol. 1, 2 dimethyl propanol.